I wish. I also would like to sleep today. We're not sleeping.
So why don't we just all agree we did it and like not do it?
I can't do that because I'm like actually paid to be here and do a job. Okay. And I just recorded myself saying that. How did y'all start? How did y'all start?
-6 or +6.
Plus 6, absolutely. 2 times absolute value, 5x minus 4 equals 3. Now I want to divide it by what, Aiden? 2.
And that'll be 7.
That will be 7. Thank you, sir. Then what? I'm going to add 4 to both sides, right? Ah, very good. So you can't trick you. Do the 2 equations. A positive version and a minus version. Now we add 4 everywhere, right? Add 4. 5x equals 12. No. I told you I was faking it. Okay, 11. I'm not even faking it till I'm making it. I'm not even making it. I'm just failing. Yeah, 5, right? So x equals 11/5, which is fine. We're the boss of the fractions. We're not scared of them. Are we? Maybe a little bit. Terrifying. Divide by 5. What? Another fraction? So x can equal 11/5 or -3/5. One or the other, not both at the same time. Raise your hand if you got that right, either on paper or in your brain. In your brain? Okay. All right, here are some notes for us today. What we're doing today is absolute value inequalities. Whatever.
Oh, that's not what I threw.
It's not.
I didn't throw anything. Oh. So you just incriminated yourself. In your phone, bro. I'm here all night.
Okay. So we have absolute value inequalities work 2 different ways. One way is for when it's less than, one way is for when it's greater than. And if you're still sort of stuck and you can't, when you see the symbol, you can't remember whether you should be calling it less than or greater than, remember the less than symbol looks kind of like an L, right? That's been rotated a little bit for less than.
Well, how I was always thought is
Yeah.
you can make an L and an R.
Oh, can you? How do you make an R? Oh, like this? Like you could make an R there?
We should straighten out and like make a and then down on the bottom.
It's like an alligator and draw teeth. And that's the side it eats.
Oh, how it eats. No, but that's for figuring out if it's bigger or smaller, right? Right here. No, that one, yeah. So what do you do? Oh, okay, so that one's like an L and that one's like an R. Thank
They
you.
always told us that it's the O like scrunched up. We
Oh,
learned really weird with.
I like that. All right, thank you, sir. I don't know. I don't know. So here's how I'm going to start talking about the less than inequalities. I have a question, this question for you. Which numbers have an absolute value of less than 3? That's in words. I'm going to show it to you in symbols in here just a bit, but first I want us to fill in the number line with numbers that satisfy that question. So give me some number that has an absolute value that's less than 3. 2? Okay, what else? 1, what else?
Anything down.
Anything down?
No.
Stops where? At the -3, right? Very good. Now, it doesn't say it can be equal to 3. So -3 itself doesn't work. So I'm going to put an open circle there. +3 itself doesn't work for the same reason, but anything in between would work, right? Decimals would work as well. Like 1.5 right here would check out, right? So, and anything between there and there and there and there and there and there and there. So basically any number, integer or decimal that you can find here would work. Now I'm going to put some symbols on this problem. I asked you which numbers have an absolute value of less than 3. That's words. Here's what it looks like in symbols. Which numbers, I don't know what they are, so I use an X. Which numbers X have an absolute value that's less than 3? So that's symbols for the words that I just told you. And this picture right here, this number line is the answer. Okay, that's the answer to the question. Now we're going to put that answer in symbols. So this picture in inequality stuff looks like this. All of this shaded region can be represented by x. The left boundary is -3, and the right boundary is +3. And then we just put those less than signs in there. And this is the basic format for what we're going to use anytime we have a less than inequality. We're going to take this form and rewrite it in that form, okay? And that's the reason why, that number line. So for this example, let's talk about how we went from there to there. We took the x out of the absolute value and we wrote it here, and then we took the 3 and we made a negative version and a positive version. So in this first example here, if I did something similar, I'm going to take out the stuff in the absolute value. What is that stuff? I'm taking it out. What is it? What's in there? In example 1. What's inside? 5x minus 6. Write that down. 5x minus 6. So we're taking, here was x, here it's 5x minus 6. So we're taking it out of the absolute value, we're writing it down. The absolute value bars are gone. And then I'm going to take that number 4, I'm going to make a negative version and a positive version, just like we did with those equations that we've been working on the last 2 days. A negative version goes on the left, positive version goes on the right, and then whatever your symbol is goes here and here. And this time it has an equal bar, but everything works just the same. It would be 4, not 3. Thank you, Megan. It would be 4. It would be 4 here and a 4 here. My apologies. -4 here and +4 there. And so now, this is something we call a compound inequality because it's more than one inequality together. If it wasn't this complicated looking, and if it was just something more simple like this, 5x minus x equals 3, what would you do to both sides to start solving? You add 6. We're going to do the same thing here. It's just there's 3 different places we have to do it. We have to do it to the middle, and the right side, and the left side. Okay. So on the left, that gives me -4 plus 6, which is 2, less than or equal to, what do I have in the middle now? 5x, less than or equal to 4 plus 6, which is 10. And what do? Divide by 5. So this is 2/5, less than or equal to x, less than or equal to 2, right? So when we solved absolute value equations the last 2 days, how many solutions or answers did we get? 2. But inequalities is a range of values. How many solutions are here? A lot. Infinitely many. It's everything you could possibly find that's greater than 2/5 and less than 2. Okay, any number there, you plug it into that inequality and it would work. Right? So you take a minute and you try example 2. Take a moment. You're going to tell me what to do and I'm going to write it down. You're the narrator, I'm the scribe. So anyone, just tell me, what do I do? Very good, thank you. -5 from both sides. And then what? Oh, you said?
You just cancel.
Did I do something wrong?
Yeah.
I feel like that's right.
That's right.
Okay, okay. Who got that right? Who ninja'd this problem? Okay, perfect. Good job, ninjas. All right, so that wasn't so bad, right? So now we're going to talk about greater than inequalities. And then once we throw in this new thing, now you're going to have to remember the difference between them, and that might be a little bit ugly. But you can do it. You're going to be fine. So greater than inequalities. We're going to start out, I'm going to ask you the same thing, but now with greater than. Which numbers have an absolute value of greater than 3? 4, 5. Does 3 work? Does 2 work? No, so it looks like everything to the right of 3. Not all real numbers, because these don't work. That doesn't work, that doesn't work, that doesn't work. What? -4, -5. Anything here, right? So kind of like any number that didn't work for less than works now for greater than. Oh, just because we're talking about absolute value. So now watch when I put it in symbols. In words, we said which numbers have an absolute value greater than 3. Here's what that looks like in symbols. Which numbers x have an absolute value bigger than 3? So like if I took -5 and put it in there, well, what is the absolute value of -5? +5. And is that bigger than 3? Yes, right? And so then here's how, so like over here on the left-hand side, this was how we went from the absolute value inequality to the compound inequality to solve. And here's how that's going to look here. To go from this to a compound inequality, looking at just this left interval from -3 to -infinity, that's all values of x that are less than -3, right? You feel good about that? Because less than means you're going out to the left. Or, for this right interval, it's all values of x that are bigger than 3. Right? So here's kind of what's going on. Here are the similarities between the first inequality form and our absolute value equations. The absolute value bars get dropped and we write down x and x. We make a negative version, but what happens to the symbol there? Flips, and that makes sense because when we're solving inequalities, anytime you multiply or divide by a negative, what do you do with this symbol? You flip it. So if I'm making 3 into -3, I have to flip the symbol. And then on the right-hand side, it's the exact same original thing, but with a positive version. And since it's positive, I didn't have to flip the symbol at all. So I bring down the x, I drop the absolute value sign, I make a negative version and a positive version. Just remembering that for this negative version, we flip the sign. Okay? And technically, even over here on this side, we flip the sign for the negative as well, because, I don't want to talk about that. I don't want to confuse you or give you any more information. Blah. So here's how this will look for our first example. We take the 2x plus 3, we take out that stuff from the absolute value, we drop the bars. We write it down. We make a negative version, remembering to do what with the sign? Flip it. And we make a positive version where we don't have to change the sign at all. And then we just solve both of those separately, just like we did them. So this is still a compound inequality. We just minus 3 to both sides, blah, blah, blah. Math, math, math. Divide, divide, divide. So we get x less than -4, or math, math, math. Solve, solve, solve. X is less than 1. And if you were to graph that, it would look just like the one in the example. It's everything to the left of -4 and everything to the right of 1. Okay? So you try that example 4 there, and then we'll finish off. We still have a back to do, but you try that one. I made a mistake right here. Do you see Marcus found my mistake? I flipped the inequality right there. But that was not correct. I went rogue. That's greater than. That's greater than. Okay, now try example 4. All right, let's begin. You have to make a negative version and a positive version, right? So I'm going to drop the absolute value bar, make a negative version. What do I do with the symbol? Flip it. Make a positive version, don't flip it. What'd you do to both sides after that? Add 4. Sorry, that was loud. Less than or equal to 2, then what? Divide. Got 2/3? Okay. Oh, yes. I don't even know what's up with me today. I'm ready to go. Thank you. So then I add, the coffee. I don't know what, I missed something. Probably glad that I missed whatever you're talking about. Yes, is that what y'all got? Okay, so let's talk about on the back. On the dukes. Some applications, that means a real world problem. Take a moment and just read it to yourself in your brain with your eyeballs. Okay, so you've read the problem. How do you feel about that problem? It's cute. Yeah. It's kind of got some wordy words in there, so let's talk about what those mean. It says absolute value inequalities are often used in manufacturing process. That's just like, a building and they're just making parts, like they're putting them out, boom, 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 making parts for bigger machines. An item must be made with near perfect specifications. That means if something has to be 10 millimeters long, it has to be as close to that as possible, or they wouldn't be able to use it to build whatever machine that they need to use that part for, right? Because it wouldn't fit. So it has to be almost perfect. And it says usually there's a certain tolerance of the difference from the specifications that is allowed. Here's what that's talking about. A tolerance means, it's like, have you ever heard someone say, oh, I had 50 M&Ms, give or take a few. Like, you've heard someone say give or take, like give or take 1 or give or take 3. That number, when you say give or take, that number is a tolerance. It means on either side, it could change by a certain amount. Like wiggle room, that's exactly right, wiggle room. So the tolerance here is the wiggle room allowed from how the part actually came out of the machine and what it was supposed to measure. And so here, and then this formula right here is how we're using the absolute value. You take the actual part from the machine minus whatever it was supposed to measure. And that difference, okay, so this word difference right here means to subtract. See the subtraction right here? So the difference between those two things has to be less than or equal to whatever the wiggle room was. I like that wiggle room. All right. And the reason why it's absolute value is because, look, like let's say your part had to be a certain length. If it was longer and you subtracted those two things, you'd get a positive difference. But if it was shorter and you subtracted those two things, you'd get a negative difference. But you wouldn't tell someone it's -2, inches off. You'd say it's 2 inches off, regardless of the direction, whether it was longer or shorter. You'd still just say it's 2 inches off, right? You'd give a positive answer, which is the absolute value. So we're going to use this formula for these problems. Example 5, I'll work for you, and then I'll let you try example 6 just to make sure you had the idea down. And then after that, we have a quizzes on your phones, okay? And that's not going to take too long. So it says the ideal diameter of a rod needed for a machine is 60 millimeters. The actual diameter can vary from the ideal by 0.075. There's your wiggle room right there. That's the tolerance, the tolerance or the wiggle room. I'm going to use that forever, wiggle room. Thank you, Megan. So the ideal is 60. That's what we really want it to be, but we don't actually know what we're going to be getting. That's the actual thing is what we don't know. So we'll put an X there. So here's our formula. We have actual minus ideal has to be less than or equal to the tolerance. So the actual is the thing we don't know. Okay, that changes from time to time. It varies. So we put a variable in there. Minus the ideal measure, which is 60. That would be perfect if it came out to be 60. And then the absolute value of that, whatever that measure is, has to be less than or equal to my wiggle room, which was 0.075. Right? So this is a less than inequality. Which method was that we learned on the front? The first method or the second method for the less than? Was it left or right? First one. Was the first one. So for less than inequalities, you drop the absolute value. You make a negative version out here and a positive version over here. And this is really easy to solve for. I only have to do one step. What's that one step? Add 60 to both sides, or all sides rather. And this will give me 59.925 and 60.075. So the x, which represents the actual length of whatever the part that came out was, has to be between 59.925 and 60.05. And so, but don't forget that a word problem needs a word answer, and it needs units. So we would say the range of diameters is between 59.925 millimeters and 60.05 millimeters. Okay, not a lot of wiggle room, but some. Have you ever seen those videos like how did they make that or whatever, and you see a person on the assembly line and they're just eyeballing it and they know exactly just from look what stays and what doesn't. So keep that, because they've become masters at just being able to figure that out real quickly. All right, you try example 6. Tell me how you set up the inequality. This step right here. What did you write? X minus 80 is less than or equal to what? 0.009. And then you broke that up into a compound inequality with a negative version on the left and a positive version on the right. And then added 80 everywhere. And what did that give you on your left? Good. And on the right? Okay. I'm not going to take the time to write the sentence, but if you were finishing out this problem, you would write the sentence and put the units, the millimeters back in, okay? But we're not going to do that because I want us to get to the quizzes.